guys, let's get started by creating a new class here. We will going to call this class employee with a public static void main. Now that we are starting to revise the concepts of object-oriented programming, remember the classes are generally created so that you can create an instance of the class. So these classes are like a template, and an instance is like a particular implementation of that idea. That's what the instance is. For example, in chapter number 1, we looked at the dog class, and then we looked at particular implementations of each of the dogs on their shot status. Exactly the same way, your class is a template, and then for each item in that template, you have to designate the infrastructure. For example, each and every employee has an ID. So you will create an ID attribute. Now notice that we create the class attributes as private because we do not want them to be directly accessible from the outside. Therefore, we create them private. So how do we make them accessible? We write getters to help get the attribute, and we create setters to help change the attribute value. That's the whole purpose of creating these getters and setters, and they're public so that they can be used to access the attributes which are private. Getter, as the name tells you, has to have a return type, and setters don't have a return type. Second thing to keep in mind is that both getters and setters are non-static. So non-static methods are those methods which help you tap into a particular instance of a class and only grab values from its memory. They cannot see elsewhere. If it's static, it cannot tap into an instance memory. It rather taps into the entire class's memory. So that's one main distinction between the two. Therefore, anytime you create a getter or a setter for an attribute, you got to make sure that it is non-static. How do you create a non-static entity? You simply drop the word static. So for example, the getter is public integer. Why integer? Because it will be returning an integer attribute. So get ID. The word get doesn't really has any meaning in Java. We just use it as a naming convention. So anybody who is looking at it will know right away that it is a getter. Setter, on the other hand, is public void set ID and it allows you to set the value. So now that you have a getter and a setter, you can easily set the value for the ID attribute. The main method, I can create two instances of employee type. If you notice, they are created exactly the same way that I create a scanner instance. So you have a class instance equals to new, and the special method we learned about last week is constructor. So there are some properties of a constructor. Constructor never has a return type and always has the same name as class. And now I can call the setter on E1 to set the ID. And then I can call the getter on E1 to get the ID. And when I run it, all you get is 344 back. So the whole idea over here is to create an attribute of a class And then after you create the attribute of the class, you call the getter, you create an instance, first you declare the attribute, then you create the getters and the setters on that attribute, then you create an instance which can call those getters and setters to work with the attribute. So this is a review from last week. Again, so I'm going over those concepts again with you guys, that whenever we create a class with attributes, the attributes are private, non-static. The getters and setters are also non-static, but they're public so that you can work with those attributes. And then in the main method, once we create an instance of the class, we can then call those getters and setters. Okay? Now, the next thing I'm going to talk about here is that what is different about the constructor method from any other method? And the answer to that question is that generally methods are created in camel casing, right? Look at the get ID and the set ID. The first word all lowercase, the second word starts with an uppercase letter. So method names are generally camel case. The only exception is constructor. That's why as soon as you see a method, the identifier is the parentheses, right? Anytime you see a method that the first letter is uppercase, it got to be a constructor. I mean, like, there's no other way. There is no other way in Java writing convention that you would write a method where the first letter is uppercase. It has to be a constructor. Okay, so that's like a visual indicator. Now, let me declare another instance, E2. And let me call this one employee 1 ID and employee 2 ID. What do you think the ID of the employee 2 will be? Anytime you do not assign a value to a primitive type, it defaults to its data type value, which for numbers is 0. Okay, so that's why when you run it, it will tell you the employee ID 2 is 0. Because then it will default to its data type default. Now, if I would like my E2 to get a value, right now the only way is to call a setter. However, there is another way for E2 to get a value other than 0, and that is through a special method called constructor. You would be like, well, the constructor is already there, but the problem is I never coded it, system did. And when system codes a constructor for you, the system will always initialize all values to their default data type values. So now I will write my own version of constructor. So I'll say employee, I want the ID to be 500. So anytime a constructor gets called, ID will be initialized to a value of 500. Now go ahead and run this. And notice employee ID 2 is not 0 anymore. It has now been defaulted to what value? 500. Now, let's overload the constructor, which is we're going to have one version of employee with no parameters and one version of employee with one parameter. So I've overloaded. So this is called overloaded constructor. And this would be called the default constructor. So now I am transitioning into chapter 4, where we talk about overloaded functions. So we also talk about overloaded constructors. Okay. So now, after you do that, let's come back to main and introduce a third instance of employee type. And this is another way you can introduce an instance, is follow on the same line before the semicolon. And this time I'm calling the overloaded constructor. So as you can see, E2 calls default, E1 calls default, but E1, after calling the default, overwrites it with 344. So that's why it's not 500. E2 does not call set ID, so it is 300. It is 500. E3 calls the overloaded and sets itself to 345. So now when you run this, oh, I need to call the getter on E3 now, and that will going to make it show you the output of 345. So that's one concept we learned this far, and that is how to create an overloaded constructor. And what's the whole point of creating a constructor? The whole point of creating a constructor is that it helps you initialize the properties with their initial values other than their defaults, which is given to them by their data types. Now, having said that, we will now fix the next issue. Notice on line number 19, I have I, and on line number 20, I have I and ID. So I'm using two different names. I'm using a different name for my property, which is ID, and from the parameter, which is I. Generally, Java developers would not do that. They would use the same name for the property as well as the parameter. But here comes the problem. If I do that, if I make this I and ID, notice the color of this ID on the left-hand side changes from blue to brown because now it has lost track of the ID on the left is actually a property. It thinks I'm assigning parameter back to itself. So to overcome this problem, what you do is you associate the property with this keyword, which means that this is the property. In other words, the most easiest explanation would be this is the property and the other guy is the parameter, which is not with the this. So whenever, let's say, E1 calls set ID, right? And it passes a value 344. So now this refers to E1, who is the caller of set ID. So that's what this means. It is a reference pointer to the calling instance. That's what this does. So now it changes the value, okay? I can apply the exact same concept in my overloaded constructor. Exactly the same thing I'll do on lines 9 and 10. Same idea. So that's why you use the same name for parameter as well as the attribute, which is most preferred way. And when you do that, you have to use the word this, the keyword this, along with the attribute. Now let me go up and introduce another property here. So I'm going to introduce a private string name. So that will allow me to have name initialized to a value, let's say Sam, or name initialized to a value Sammy for the second one. Okay. And then I'll create another overloaded constructor where I will let the user choose the ID as well as the name. In that case, I will follow the same trend that this dot name equals to name. So if you notice, once you learn to work with one property, it is exactly the same idea. It doesn't matter how many properties you're working with. It's the same implementation idea. So I introduced a new property name, and I went to each of my constructors, and I gave it a default value, or I gave it or I basically let the user choose one in my third implementation. Now let's come down. I've not yet used this constructor, but let's come down and write some getters. So we're going to write a getter for this property string. So of course, since I'm getting a string, so it will return a value of string type. Similarly, in the second case, I will be setting the name. Everybody follow this? That if you notice both getters, they look exactly the same. If you notice both setters, they also look exactly the same in terms of the implementation, the whole skeleton idea. Of course, there will be some underlying differences in terms of return type, their names, and the returning attribute, but the idea is the same. That's basically what I want you to grasp here, that it's the same idea that you will see in them. Okay, now let me do this. Let me go down and let me make some changes to the outputs. Name E1 dot get name. Similarly, E2 dot get name and E3 dot get name. So for each one of them, you can see that for the first two, the name is Sam because they're calling the default constructor, right? And for the third one, the name is Sammy because he's calling the overloaded constructor, the first version of overloaded constructor. Okay. Now let's introduce another constructor, another object here, E4, which will now call the other overloaded constructor, the second one. And now let's display E4. And you will see that in the output, it will show you the E3 and E4 to be different from E1 and E2, because E1 and E2 are calling the default constructor, E3 is calling the overloaded, and E4 is calling the other overloaded function. Now, if you notice, in the three instances of employee type, we are repeating ourselves over and over again. It's the same lines. So it's a very good candidate for a modularization, and it will also help you learn how you can pass an object as a parameter, which you have already learned, because we have been passing objects like here. String is an object. A name is an object of type string. So we have been using object passing before. It's not new to you, but for the first time, you'll be able to pass object of user-defined type. So we'll create a static method, public static void display, and we're going to accept an employee object, and we will just copy one of these instructions and paste it there, and we'll just say employee dot id employee dot get name. So once we establish this, we will then replace these with the display call and pass different employee instances. So as you can see that your main is far easier to code than it was before. Same output though, but we have taken the whole logic of displaying the output away from the main into a module. So here we are sort of kind of bringing in static method within a non-static approach. Now let's go back to line number 6 through 18. You see a lot of repetition, like lines 6 through 9 are doing something very similar to lines 11 through 14, which are doing something very similar to lines 15 through 18. So there's a lot of repetition here. Initially, up till 5 years ago, that was the only way to write constructors, overloaded constructors. But then Java developers thought, well, this is a lot of redundancy going on, so let's come up with a way to reduce this redundancy. So which one of the three constructors is most customizable by the user?
Line 15.
Line 15. So what we do is we redirect the line 6 and line 11 constructor to the constructor on line 15, and this is how we redirect. We make a this call and pass all the necessary values as parameters, and then we do not assign them locally. So anytime somebody calls the default employee, it will automatically call the customized constructor and pass those values over. So it does not need to code the assignment instructions on its own. And we'll do exactly the same in the second one. So your output will be no different from the previous one. You'll have the exact same output as before. The only difference is that the underlying methodology has changed. So in the underlying methodology here, we will now be coding less. Now think about it. If you had like 10 properties per constructor, and you have like 9 of such constructors or 10 of such constructors, in the absence of this approach, if you are writing 10 assignment instructions at each of your 10 constructors, you're easily talking about over 110 lines of code, which you can now easily diminish to maybe like 20, 25 lines of code. Okay. One more thing I want to introduce over here is a static variable. A static variable is the one that is declared with the keyword static, and it maintains the same, it maintains the same value for all instances. For example, public static integer total equals to 0. So I have a static variable total that is set to 0. What I want to do is every time a constructor gets called, now that's another thing. Now I do not need to code it in each of the constructor. I can only code it in the most customizable constructor. So I'll say anytime this constructor gets called, I want to increment the value of total by 1. Since it is static, it will maintain the count between all instances. If it was non-static, then it will be 1 for all of them. It doesn't matter how many I create. So now I can maintain the count, and it's going to be 4 for the 4th one, 3rd for the 3rd one, and all others, 2nd for all others, I mean like 1 and 2. So it will maintain its count. So we can now display, for example, right after this one, right after I create the first one, okay? So total instances equals to total, okay? And now total instances equals to total. Okay, so I have 2 exactly same value statements, and notice the difference in the output, that for the first one it says 1 because only 1 instance was created, and for the second one it says 4 because 3 additional instances were created. So the static variables can be used to maintain across different instances, and non-static ones are used where they maintain their values for each instance separately.